To determine the appropriate size for a gas bonding conductor, refer to National Electrical Code Table 250.122c. This table provides guidance on sizing equipment grounding conductors for grounding raceway and equipment. The size of the equipment grounding conductor, which is used for bonding gas piping, is based on the rating of the overcurrent protective device in the circuit that supplies the equipment. For example, if the circuit is protected by a 20 amp overcurrent device, Table 250.122c would likely specify a certain size copper or aluminum conductor. It is crucial to consult the specific edition of the NEC that is applicable in the jurisdiction where the electrical work is being performed, as code requirements can change between editions. Now, regarding the minimum size conductor for bonding, yes, there is a minimum size specified in the NEC. According to NEC Table 250.102c, the minimum size conductor for bonding is #8 AWG copper or #6 AWG aluminum. This table addresses the minimum size of bonding jumpers and main grounding jumpers. It's important to note that while these sizes represent the minimum allowed, a larger conductor may be required depending on the specific application and the size of the ungrounded conductors in the circuit. The NEC provides specific guidelines for sizing bonding conductors based on the size of the service entrance conductors. These guidelines ensure that the bonding conductor is adequately sized to safely carry any fault current that may occur. The purpose of bonding is to create a low impedance path for fault current to return to the source, which allows the overcurrent protective device to trip and clear the fault. Inadequate bonding can result in elevated touch voltages on metallic parts, posing a shock hazard. The selection of the correct conductor material, either copper or aluminum, must also comply with NEC requirements. Copper is generally preferred due to its lower resistance and greater corrosion resistance, but aluminum is also permitted under certain conditions, provided that it is properly sized and installed. When using aluminum conductors, it's essential to use connectors and terminals that are specifically listed for use with aluminum to prevent corrosion and ensure a reliable connection. Furthermore, the installation of bonding conductors must adhere to specific NEC guidelines, including proper termination techniques and protection from physical damage. Bonding conductors must be securely connected to the gas piping system using approved bonding clamps or connectors. The connection must be made in a location that is accessible for inspection and maintenance. It's also important to avoid creating any unnecessary bends or loops in the bonding conductor, as these can increase impedance and reduce the effectiveness of the bonding system. The NEC also addresses the bonding of other metallic components in the vicinity of the gas piping system, such as water pipes and structural steel. These components must be bonded together to create a common ground potential and minimize the risk of voltage differences. In addition to the NEC requirements, local codes and regulations may also impose specific requirements for gas bonding. It is essential to consult with the local electrical inspector or authority having jurisdiction to ensure compliance with all applicable codes and regulations. Proper gas bonding is critical for ensuring the safety of electrical systems and preventing electrical shock hazards. By following the NEC guidelines and best practices, electricians and installers can create safe and reliable gas bonding systems that protect people and property. Understanding the principles of grounding and bonding is fundamental to electrical safety. Grounding provides a reference point for the electrical system, while bonding connects metallic parts together to create a low impedance path for fault current. Together, grounding and bonding help to minimize the risk of electrical shock and fire. The NEC provides comprehensive requirements for grounding and bonding in Article 250. This article covers a wide range of topics, including grounding electrode systems, equipment grounding conductors, bonding jumpers, and methods of grounding and bonding. Electricians and installers must be thoroughly familiar with Article 250 to ensure compliance with the NEC requirements. In addition to the NEC, other industry standards and best practices can provide valuable guidance on gas bonding. For example, the National Fire Protection Association, or NFPA, publishes several standards related to electrical safety, including NFPA 70E, Standard for Electrical Safety in the Workplace. This standard provides guidance on safe work practices for electrical workers, including procedures for working on or near energized equipment. The Institute of Electrical and Electronics Engineers, or IEE, also publishes standards related to electrical grounding and bonding. These standards provide more detailed technical information on the design and installation of grounding and bonding systems. Staying up to date on the latest codes, standards, and best practices is essential for electricians and installers. The electrical industry is constantly evolving, and new technologies and techniques are constantly being developed. By continuing to learn and improve their skills, electricians and installers can ensure that they are providing the safest and most reliable electrical services possible. Furthermore, regular inspections and maintenance are crucial for ensuring the continued effectiveness of gas bonding systems. Over time, bonding connections can become loose or corroded, which can increase impedance and reduce the effectiveness of the bonding system. It is important to periodically inspect bonding connections and make any necessary repairs or replacements. During inspections, it is also important to check the condition of the bonding conductors to ensure that they are free from damage or corrosion. Damaged or corroded conductors should be replaced immediately to maintain the integrity of the bonding system. Proper gas bonding is not only a matter of compliance with codes and regulations, but it is also a matter of professional responsibility. Electricians and installers have a responsibility to ensure that their work is safe and reliable and that it protects people and property from electrical hazard. By taking the time to understand the principles of gas bonding and following the NEC guidelines, electricians and installers can fulfill this responsibility and provide valuable services to their customers. So, in summary, firstly, consult NEC Table 250.122c for size and gas bonding conductors, using the overcurrent protection rating to determine the appropriate size. Secondly, remember the minimum conductor size requirement from NEC Table 250.102c, which is #8 AWG copper or #6 AWG aluminum. Thirdly, ensure proper installation techniques and use appropriate connectors and terminals. And fourthly, maintain and inspect the bonding system regularly to ensure continued effectiveness.